Hello everyone, today I'll be going over the intuition behind why is marginal revenue twice as steep as demand. So let's first look at a simple example here. I put an inverse demand function over here, which is writing P in terms of Q instead of writing Q in terms of P like we normally see a demand function. It is for simplicity purposes, and also it's easier for me to analyze further. P, which is equal to 24 minus 1Q. I will highlight this to simplify analysis further. Total revenue is calculated by P times Q. So we basically use this P function and times the quantity demanded gives us the total revenue earned by this firm, which is 24Q minus Q squared. The marginal revenue is actually the slope of total revenue. Another definition of marginal revenue that you're maybe more familiar with is the actual sales revenue generated by producing an actual unit. So it's basically differentiate the total revenue function. It gives us 24 minus 2Q. It's basically differentiating this function. And it is illustrated in the curve over here. Like I've circled over here is a 12 and the other intercept is 24. So we can actually calculate the slope of these two functions, which is negative 2 in this purple line and negative 1 for this blue demand curve. So it's essentially illustrating the relationship that I outlined above, negative 1 and negative 2, which is exactly twice as steep. So please note that the twice as steep notion is only true in monopoly case, and we actually have the assumption that the demand curve is a straight line demand curve, and if we use a more realistic curved demand curve, that will not be the case because there won't be a constant slope. So just to provide you with more intuition about the relationship between marginal revenue and average revenue, I would like to give you a mathematical proof of the relationship between the marginal revenue and the demand curve. So let's dive into this. The marginal revenue, as I have explained above, is essentially the derivative of the total revenue. So here's the total revenue. Taking the derivative of that in terms of the quantity. So we first write the total revenue as P times Q. So when we differentiate these terms, the chain rule actually kicks in. So we first differentiate the second term, dq over dq, and then we times the first term. Plus, we differentiate the first term, which is dp over dq, and we times the second term, which is q. So that is basically the chain rule. If you haven't taken calc before, you can refer to some websites which will explain to you what a chain rule actually is. So that will comes down to pq times dp dq times q. So I want you to actually look at this term over here, which is dp over dq. So essentially, it is asking the relationship between P and Q. So because we are dealing with a demand function, and all of you might know the law of demand, which is as the price increases, the quantity demanded will decrease. So the relationship between these two is actually negative. That is essentially what this derivative actually means, is the relationship between these two subjects. So as it is negative, it will essentially be simplified as this equation will be marginal revenue, which is equals to the price minus a let's say a constant E times Q. So E is a positive constant, so it's essentially P minus a positive number. So P minus a positive number gives us marginal revenue, which implies that P is greater than marginal revenue. Now, be careful here. A hidden assumption under this mathematical proof is that the firm had some sort of market power. So P can actually equal to marginal revenue when the firm has no market power, meaning that the firm cannot control the price. That is the case in a perfect competitive market where the firms are actually price takers. They cannot influence the price in the market. And also, the final point I want to mention is how do we relate marginal revenue to the concept of elasticity? We can actually further written that in terms of elasticity, as you will see in a second. We will take this function down to here, which is P times dP dQ times Q. Then we leave the first term as it is, and then we take out a P and we divided it, so it's essentially 1. So it doesn't influence the initial term. So then we multiply out a P term, and the first term gives us 1, and the second term is basically the inverse of this whole thing. And look at that, it's so elegant. It's exactly the elasticity of demand, the price elasticity of demand that we have learned in previous lectures or previous videos. So here is essentially price times in the bracket 1 plus elasticity under 1. It's 1 over the elasticity. So that will basically tell you that the marginal revenue earned by the firm, or the control over price that the firm has over its products, will be determined by the elasticity of demand. And that makes a lot of sense, because if the price elasticity of demand is really high, meaning that the consumers can switch brand easily, then the firm won't be having as much of market power as it would have if the elasticity of demand is pretty low. So, and also, this elasticity of demand won't be below 1. The reason behind that is the firm will most likely operate in an inelastic portion of the demand curve, which is this portion of the demand curve. As I have explained in the previous videos, why this portion is inelastic, because the firm will avoid that section because that will not give them as much revenue as it would in the higher sections, mainly because the monopoly usually wanted to charge a higher price, while setting the quantity low, limiting the quantity. So that's basically this whole video, and hope you enjoy. Thank you.